Okay. So evolution is just change over time, really. So evolution by natural selection is it's just a process that basically causes adaptive evolution or adaptive change. And the best way of really explaining it is using an example. So let's just say we're probably going to talk about running at some point. So let's just say that you have a population, and these individuals vary in their ability to run, right? So some are just stronger runners than others, some are weaker runners. Now, those stronger runners are going to be more likely to get away from, say, a dangerous predator pursuing them. Which reminds me, you saw that article, right? That was about the Park Service is saying don't push a slow friend over when you're running from a bear. And all I could think about is like, why not? But then I was like, well, it said it was a slower friend, so you don't need to push over a slower friend. They're already slower, so maybe they're just saying, hey, be more efficient and just keep running. Don't waste your time pushing this person. Or if they know that you're gonna push them over, then they should want to push you first. And then if you just keep following that logic, every time people see a bear, they just start fighting with each other. But anyway, you can imagine that that faster runners or stronger runners are going to be less likely to be captured by a predator. They also are more likely to probably acquire food and then therefore have offspring, leave descendants. Now, let's just say that ability to run better, maybe it's like because you have more efficient muscles, whatever. Let's say that ability is conferred by a gene, a certain gene that these individuals have. And that gene allows them to be better runners, to then have them have more offspring who are also going to have that gene, compared to the alternative gene. So you could see that in successive generations, that gene should become more and more and more common. And you could imagine another mutation pops up, let's say, that maybe increases the length of the Achilles tendon. It makes a more efficient runner, a more effective runner. Well, then by virtue of that gene and that conferring that trait, those individuals are going to then, again, leave more descendants than individuals that have the other gene. So you'd imagine that the gene is going to become more and more and more common from just a very random beginning to now you have non-random sort of reproduction. And then that's basically the process. So it obviously is a very powerful framework to understand why things are the way they are. It explains many things even outside of biology, when you think of like why airplanes are better now, because the first airplanes weren't that effective. They're just falling right out of the sky, and you see all the different ways they tried to fly, all these different strategies that they used. And the ones that worked, that the traits that conferred an advantage in flight, those traits were differentially reproduced, by these engineers. And then you vary on that theme, and then you take the best of those variants, and then you vary again, and you take the best of those. And then now you have things like, these nice passenger planes and jumbo jets, and they're still going to get better because they're introducing new variation and new tinkering with things. And the ones that work or more effective are going to be differentially reproduced. So it's the same process. You're just really varying what's doing the selecting part of it, but it's a really intuitive and very simplistic process. But again, it really helps you understand why things are the way they are.
So just quick question, Omar, that would be a cool point on that, and not to go off topic, but I think it is kind of on it, because everybody likes to identify themselves with being the most evolutionarily fittest, or particularly today. So in terms of when you say, just quickly in this analogy, someone might say, well, the best runner is Usain Bolt. Someone might say, no, it's a Roger Bannister-like runner, the miler, or some might say it's Kipchoge, the marathon runner. From just a pure survival perspective, and I know the whole thing isn't about running, but what are we calling a good runner? The miler, the sprinter, or the distance runner? I'm just curious on that.
Oh, no, it's a great point, and that's why I kind of left out. I was like, a stronger runner versus a weaker runner. It's deliberate there. Now I got to explain it. So the idea there was we're adapted for endurance running, for having a relatively light body, running at a moderate pace, over pretty good distances, efficiently. So we're not really explosive, but you have to keep in mind that we're from a lineage of athletes. We're a primate, and all the other primates are just zooming around in trees, and that's pretty athletic to do that. You need explosive power. I mean, they can outrun us easily. A chimpanzee can outrun you. I mean, easily, can easily overpower you, can easily climb faster. So that's really the foundation of like kind of how our bodies were, of these being these explosive sort of athletes. But later on, due to environmental changes and obviously selection, favored us to be endurance runners. I can get into that with much more detail if you like, but the idea is that really it favors us to be great endurance runners. So really any mutation to those genes that confer explosive athletes, anything that would maybe take down some explosiveness but make that more efficient instead, that gene will now be favored. But before, obviously, that would be selected against. But now that more endurance-oriented gene is going to be favored. So that's why most humans are actually, I would say all humans are better endurance athletes than the classic mammal out there. But yes, of the human population right now, some are better at endurance and some are, again, better at speed. But even the speedsters that we have in our population, like Usain Bolt, yeah, he's fast for a human,
Right.
But he's not fast compared to even like a house cat. He's not catching anything with that kind of speed, And nothing against Usain Bolt. But he's
great
not going to catch anything with that speed. However, again, even though you think of him as a sprinter, he would be a much more efficient runner than any other quadruped that's out there,
Yeah.
But compared to other humans, yes, he's a much more explosive athlete compared to all endurance. And that being said, so you can imagine, again, like a lot of these explosive, athletic genes were essentially being selected out in favor of more endurance genes, because again, those explosive genes are really a liability over the long haul, over a great distances. So they're going to be selected against. However, before that genes were completely, or wiped out or replaced, I should say, then we invented more explosive hunting tactics like bows and arrows, and then now explosive and stuff like that can actually be very beneficial still in the environment.
Throwing,
so that's
right?
why exactly. So that's why they weren't like, there was a time at which obviously was a selection, very strong selection for greater and greater efficiency and endurance. But ultimately, like it wasn't exclusively that way, because we went away from the persistence hunting with more explosive strategies before essentially those genes were completely replaced. But you could obviously imagine that an athlete like, say, LeBron James, a fantastic contemporary athlete, when you have calories to, give away,
Exactly,
and stuff like that. But an athlete like him would not be the one you would want in your tribe necessarily for endurance, persistence hunting, because like this thing's got to eat, twice as much as I do, and it's going to get tired and all this other stuff, but you can, those traits can actually be adaptive in this modern environment, but they would probably be very strongly selected against in the ancestral environment.
very cool.
Yeah. Now, I remember you talking about how there's a certain speed that humans can run or trot. I forget what the terminology is. That is just fast enough that if they maintain it, the herbivores, the four-legged animals, their top speed obviously is faster, but their ability to thermoregulate just isn't that good. So explain, and this dovetails into why we're endurance animals. Explain how that works again.
Yeah, so to get at, we hunted using persistence, which has got to be terrifying if you're an animal. So when you really think about it, for almost everything that's out there, hunting other things or trying to get away from being hunted, it's all about explosiveness. It's really a sprint, and the animal that wins that sprint either gets to survive or gets a meal. It really depends on which side of the equation you're on. But really, it's just an explosive event. And you only have to just athlete that other individual in a very short term. But obviously those things would be a liability over the long haul if you had to then have this, do this for a longer period of time or cover a greater distance. But they never have to do that because nothing's chasing them over great distances. It's always sprint. And then, about 2.5, whatever million years ago, all that changed, and we start running after these things. And all of this all the selection before we showed up, all of that was favor them to be, again, more explosive, to get prey, to get away from prey. And now here we are, and we completely use that trait of theirs as a liability. And now, because we're efficient, we're on two legs, so automatically we're more efficient. And again, we have a series of genetic mutations in our muscle, how we form a muscle. So we're in a more slow twitch versus high twitch, that kind of balance. So ultimately, it makes us really good at sort of not explosive to catch them right away, but as long as you can kind of see where they're going, they're going to get tired by the time that you're going to be able to catch up to them, and they're going to be tired. And then when you catch up to them again, they're going to act how they normally would act with every other predator that's out there and sprint away as fast as they can. And you can imagine if you were just doing a workout and you had a friend, you go, you just sprint off as fast as you can. I'm just going to start jogging. And when you get tired, go ahead and rest. I'll just keep coming to catch up to you, and every time I catch up to you, you guys start sprinting again. They're going to be passed out before you even make it like a mile, and you'll be perfectly fine. So imagine that you're doing that to another animal that is really, really fast, but also not really, really good at all with endurance. And we can sweat over our whole body, so we can literally cool down or using our whole body. Most mammals can only sweat from their palms. They have to literally stop and pant to cool down to get that evaporative cooling. So we're jogging after these things. And again, their bodies have been shaped for just exploding away, exact opposite of what we're exposing them to. So they're going to just erupt away, and they're just falling right into our trap, essentially. And we just simply out-endurance them. It just becomes like a endurance game of chicken, where it's just like whoever passes out from heat exhaustion first dies. So yeah, but you can imagine that any other animal that would be like us and be a moderate speed endurance thing, not really explosive at all, you might be also vulnerable to predation yourself. But we got big brains, we could throw things, we can have fire. So ultimately we can hunt using that strategy that everything else has as a liability. But at the same time, it's not a liability for us, because it doesn't put us in a bad way, because we can make up for it with having, again, like weaponry, and you could pelt an animal with rocks, a bunch of doom, 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 it's going to start running, doesn't matter how big it is. So yeah, so that's basically why. So getting to the running pace thing. So coincidentally, our efficient endurance running pace is just fast enough to force a quadruped, a four-legged animal, from going to a trot, which is not as bad for it, into a gallop. A gallop, it's really jumping from front to back. A trot, it can kind of do that for a while, but it's just like you can only walk so fast, and you got to start jogging. And even if you're jogging really slow, you're still doing something different than when you were walking, a different gait. And you can see that with these quadrupeds, going from a trot to a gallop, even if it's only a little bit faster, even if it's a slow gallop, it's still much more costly than a trot. And our endurance, our comfortable endurance running pace of humans is just fast enough to force these African quadrupeds to go from their trot to their most inefficient form of locomotion. So we basically just brutalize these things. Again, they're getting hot, they're getting tired, and they're just, you can't outrun exhaustion. You just can't do it. That's the one thing you can't outrun, is getting exhausted. So you can imagine that we were extraordinarily successful in this strategy. And we picked a big animal. You're not like a lion, you go after the sick or the weak one. You go the big one right there with those big old horns. That one.
More meat, more fat, right?
I mean, it's gonna get tired carrying these big horns running around.
And you get more from it.
Yeah, but in every other walk of life for that animal, being bigger was better. But only when humans show up is the biggest individual now the most disadvantaged. So again, you just blast it with a few rocks, and it just goes, and it starts running away, and then it runs to its doom, and it just passes out from heat. It might just pass out dead. And all you gotta do is make some tools and, dress the animal right there, and you got food. So
how terrifying is that? You're being chased, and the chaser just won't get tired.
Yeah, I mean, just imagine that. It's like it's like at least you get the quick death if if a lion's going after you. It's gonna just roar and just get you and just choke you out, and that's the end of that. But being pursued to exhaustion, I imagine that's just like it's like being in like a plane crash where you're just like, oh, the plane's going down. I mean, we're gonna die in a few minutes. Like it's gonna happen in the distance. It's not just like you got surprised by it, So I imagine it's pretty it's pretty horrible situation to be in.
No, this is fascinating stuff. I've always loved evolution, and it's one of my favorite classes as when I was an undergrad bio major. I have like 500 questions, Tony. So if you have any to ask away, because I have a whole list.